Good morning, everybody. Everybody can hear me okay? I'm fortunate to be here today. I appreciate the invitation. As was introduced, I work at the State Water Resources Control Board, and I've been working with PFAS now for almost 2 years. I am actually a geologist by background, but I got plucked out of the realm to help lead this effort. And I really is great to see some folks here today that we've been working with and collaborating with over the years on this topic. So we've been working in this arena, like I said, for a couple years now. We've been kind of leading the efforts and try to understanding the presence or absence of PFAS across the statewide. And both not just at these industrial source sites that Ned was mentioning, those airports, landfills, and wastewater treatment plants, but also in public drinking water supply. It was very important for us in our approach that we needed to protect the public drinking water supply as our number one effort in this state. So I'm going to summarize kind of our journey that we've taken so far today. From when we started, we included some pilot studies, some comparison studies, so I'm going to go over those and where we are and how those kind of built upon themselves. We were also very fortunate to get some fortuitous legislation that provided us some money to actually do some really great work that is currently going on. And how those partnerships have guided us today moving forward. So as everybody in this room knows, right, and we've already heard this morning that we are well aware on how many number of compounds there are in the PFAS class, and regulating them one by one is just not going to happen. There's just way too many to work with. And so, and it's also, as mentioned before, it's really hard to identify them all as well. So the conventional toolbox, as mentioned, right, we have our targeted analytical testing methods, but we are also using a lot more advanced techniques, even at the State Water Board, not just at the academic researchers. We're poking our toes. Actually, I think we're about waist deep now into using more outside of this whole idea of using research-based, and I mean not using just analytical targeted testing methods. And so that includes TOP-SA. Well, yeah, we dabbled in with that. We also dabbled with PIGGY, and we are really into non-target analysis. That's going to really show us a lot. So so we needed to start to understand and compare. We started small, and we needed to kind of understand how we looked at available targeted analytical tools that are available, and we compared them against each other and against a total organic fluorine method. So in 2021, we sampled water across the state at 9 public water supply wells. They were either located near an airport or they were near a landfill. There you go, Ned. And we knew that there was going to PFAS be in those water supply wells. And we sampled those and we tested them against 4 different targeted analytical testing methods. One of them was the DoD QSM, that's the Department of Defense Quality Systems Manual. It was huge help for us because there was not a targeted method available through EPA for non-drinking water. We also analyzed those samples against methods 537.1 and 533, which are drinking water methods, and we also did TOP-SA. The total PFAS method that was used was absorbable organic fluorine by combustion ion chromatography. So that figure to the right is one of those sampled wells, right? The sum of the PFAS reported using the conventional analytical methods do not even get close to the amount of absorbable organic fluorine in that well. So What's that discrepancy? That discrepancy really triggered the need to understand what was contributing to that unknown mass in public drinking water supply. What were they? And are they being removed by treatment? So finding those answers really led us into a second part of our journey by working with US EPA Office of Research and Development and the leading experts in the investigation of PFAS, data analysis and laboratory analysis, and specifically non-target analysis. So working with, we also were very fortuitous in regards to getting advocate for funding in our 2022 budget. And so within Assembly Bill 178, tasks the Division of Drinking Water to do three things. One, to develop a broad spectrum test method for PFAS. Number two, sample all public water system wells serving disadvantaged communities statewide. That includes about 4,000 wells. And number three, we're going to develop a treatment-based regulation for PFAS as a class. So task number one is actually complete, and I will go over those results. Task two, we began that task already. It started out with issuing a general order by the Division of Drinking Water to comply public water systems to sample for PFAS. However, all that sampling is being done at no cost to the water system. Sampling began in April. We expect task number two to take us 2 years to complete in order to get around the entire state of California to sample all those wells. And number three is going to start a little bit later. We need to understand what's going on in task two before we move to task three, but we're already collaborating with other water agencies and existing treatment systems across the state to sample for those. So, how did we get to our broad spectrum test method that we selected in task number one? So the primary objective of this 2023 study was to identify the most appropriate broad spectrum analytical method for characterizing the occurrence of total PFAS in drinking water. So this method needed to be reproducible, it needed to be robust, and it needed to have a high potential to support feasible ongoing monitoring. It had to be something that a commercial laboratory could do. It could not be something that's going to be at, a research institution, and it has to be affordable for these public water systems. They're already getting dinged, so to speak, for the 533, which costs about $300 to $400, right? So we needed to make sure that we could find something that was going to hopefully will work for ongoing monitoring. And the secondary objective of the study was to characterize the chemical space that is captured by available broad spectrum analytical methods. So we went back to those same 9 wells that we did 2 years ago, but we collected them and then we analyzed them in triplicate this time. We included a broad spectrum organic fluorine methods that include AOF CIC. We included EOF by CIC and other methods that are primarily available through academic partnerships that are not listed here. In addition, field sample analysis, the study included several laboratory control spike experiments to evaluate the analytical fate of the analytical standards that represent the range of inorganic fluorine compounds and ultra short chain volatile and cationic PFAS over a range of concentrations. So the results of our 2023 broad spectrum summary study can be summarized into 2 categories of performance. One is preferred and selected, and the other one is not preferred. So for AOF CIC at those 9 water samples from those public water supply wells, we did not, it was good that we did not see any organic fluorine that was measured in those wells. We don't want to see organic fluorine as part of the PFAS. We got very good results in regards to targeted PFAS. We saw sulfonamides, semi-volatiles, and cationic PFAS. They were recovered in those samples. and we had about an 85% detection frequency using AOF. What was not preferred was EOF CIC. For us, there was inorganic fluorine that was recovered in those samples. The sulfonamides and semi-volatiles, PFAS, were poorly measured in those samples. And we had really some inconsistent recoveries having to do with cationic PFAS for the ones that were included in our study. And our detection frequency was a lot lower with EOF CIC. Preferred, based on, between the use, we used two different extracts. We used the extract using EPA method 533 and the extract for the DoD QSM method. And for use in high resolution mass spectrometry, which we're going to be using for NTA, for non-target analysis, the DoD QSM worked much better and performed much better in recovering target PFAS, ultra PFAS, and the sulfonamides. For method 533, that extraction process really encouraged losses of ultra shorts and also a lot of the losses of sulfonamides. So targeted PFAS, we also did direct. We had standards for ultra shorts. We already knew we did suspect NTA on that original 9 water samples, and so we had standards for those. So we had an idea what those were. So in summary, our chemical space is including, we're going to be using AOF CIC as our broad spectrum test method, and we're going to be doing an extraction procedure that's going to be modeled after method 1621. And yep, so we're currently collecting samples as we speak. So this graph is showing the results that we saw. For the sum of the targeted PFAS using method 533, is in that kind of that dark orange, I guess, compared to the AOF. There's the 9 wells. Not quite what we thought was gonna happen. Especially if you take that orange part off, right? So we didn't know about that orange part before, right? When we did our original 9 wells, same locations, only 2 years later, right? So our AOF, in most cases, the sum of the target and the ultra shorts exceed the amount of AOF that's in those samples. And the biggest difference are those ultra shorts, by quite a bit, actually, in those wells. Not that we have any indications that they're going to be impact human health or the environment, right? But it's good to know what they are and what the chemical space in which that we can see them in. And that's what's important for us. I'll let that chart sink in a little bit. All right, so we're gonna close this out here on our timeline where we are. So we really, those results from both that 2021 and that 2023 really led us on a journey, an adventure, right? We thought we knew what we knew in 2021. Now we know something a little bit different in 2023 in regards to those studies, right? So that is a map of all the public water supply wells that are currently being tested. We started in April. They are located in disadvantaged communities across the state. We're currently at about 3,800 wells, actually. Some of them dropped off because of different things or the other with the public water systems, right? They're going to be from Earl to Reuben, all over the state. We'll be measuring every one of those for method 533. And we need to do that because that's a public drinking water supply well. They can use that sample for compliance with other monitoring requirements by the EPA, since they just recently issued their MCLs recently. So it'll be they can use it for their initial monitoring period for that. They may also be able to be in compliance with UCMR 5, depending on the timing. And all of those samples will also be analyzed for AOF-CIC. We can't afford to do non-target on 3,700 samples. It's too expensive. So we're doing a subset. And it's going to be about 700 of them, which is a pretty good swath. And you can see the red dots. That's where we're going to do NTA, but we're also going to do ultra shorts at those same locations. We're going to use the extract from both. The same extract is going to be used for the high-res mass spec and the ultra shorts. So we'll have an idea of the abundance. We're going to know how much has been represented by AOF. Okay. We're going to know how much, targets are, some ultra shorts, right? Combination of those. We're going to know those. But that NTA, that's going to tell us what's missing, right? And then we can figure out how we're going to treat those wells as a class. Right? Isn't that awesome? Totally awesome, right? So, you can see my enthusiasm there. All right, so that's the plan. And just a special thank you. I don't know how I'm doing on time, but there's a lot of folks actually in this room that have been part of this whole thing. And and so we wanted to shout out to those folks. It's including folks from EPA. We have environmental justice groups that are involved with us. A lot of researchers that we've contacted to try to figure out how we were going to best do this as a state agency. Laboratories. So one more plug. Mr. Matt Small up there. He's been a huge advocate for us in regards to EPA and our connection to ORD. Cannot do it without you, sir. And we're going to do this at the commercial lab level. That's where we're going to do this at. So I believe we might be the only state that's doing this, and we're a little nervous. I'm a little nervous, but we're underway. So we can come back a year, and we'll have more data to show. So thank you for your time.